Hello math students. Today we are continuing with our advanced function lessons. We are going to do something called dividing polynomials, and this is a skill that you're actually going to probably look at this lesson and on first glance you're going, well, what does this have to do with looking at a polynomial and figuring out information about it? So this is actually a skill that you're going to be using on the next lesson. And probably towards the last few examples, you'll kind of see where that fits in. Basically, what this will allow us to do is take a higher degree polynomial, maybe a cubic, a degree 4, degree 5 or higher, and be able to, once we know a factor, we can actually factor that factor out and see what's left over. And then we can basically keep going until we get to something that we can factor, such as maybe a quadratic, and then just factor that. So we'll actually be doing that in the last example. So what we're doing today is, like I said, dividing polynomials. So the first thing we're going to look at is some terminology definitions, and you might remember these four, part of a package. Every time you do a division, you have the dividend, which is what you're dividing, the original thing you're dividing. The divisor is what you're dividing by, and then the result is the quotient. And if you have anything left over that didn't evenly go in, that's going to be the remainder. Okay. I'm going to do an example. I've already written it out here, so let's go through it, and you can kind of see where we are. So if I just did this with numbers, with integers, you might remember this or not from earlier grades. I think everybody learns this in grade 4, 5, 6, and then we just kind of leave it behind and we use other things like calculators. But say you're dividing 3,731 by 12 and you didn't have a calculator handy. So the way we do this would be long division. So first thing you do is you write out the 3731, and then you do this division bar, which is kind of like a, almost like a 7 on its side, or half of a T-bar on its side. Okay. Maybe I'll just erase this so you can see the steps a little better. You can kind of see them below here, but that's okay. So what we're going to do on the number we're dividing, we're going to start at the left and work our way to the right. So I'm going to start with this number 3, and I'm going to say, how many times can I divide 3 by 12? Well, the answer is I can't. So then we just kind of, we keep going, and I say, you could actually put a 0 above there if you wanted to. I can't divide anything in there, so it's 0. And then I grab the next number and put them together. So now I have 37. So I'm working with 37 and say, well, how many times can we divide 12 into 37? And the answer is going to be 3. So I put a 3 above the last digit that I used here. So I don't really need the 0, but I was just showing you kind of, what you could do. It doesn't really affect anything. Now you go back here and say, okay, I'm going to multiply these two. 3 times 12 is 36, which we kind of already knew. And then you subtract. So 37 minus 6, 36 is 1. And now you bring down the next number from the dividend that you haven't used yet. So now I have 13, and I ask myself, how many times can 12 go into 13? The answer is once, so I put my 1 up here. And now I do the multiplication. 1 times 12 is 12. Subtract, I've got my 1. And now I bring down the last number. This will be my last step because I will have now used all the numbers. And how many times can 12 go into 11? Well, it can't go in at all. So again, just like the 3 there, we put this time the 0 does really matter. Obviously 310 is a lot different than 31. And when we get to the when we get finished here, basically this number is left over that we can't do anything more with it because it's less than the divisor. So anytime you get down to there, you just stop. I usually put an equals r for remainder, and we're done. So if you look back here, there's two, call these division statements. So once you actually do a division, which includes polynomials, you should be able to make a division statement. And you can see there's two flavors of these, and I'll do both of them with the example we just did. This one here, where there's no division signs, is usually a little clearer to most people and causes fewer mistakes. So I'm going to ask you to do a division statement. It's up to you which of these forms you actually use, but I would recommend that you do the second one here. So just to see what it looks like, and you could probably make up your own mind. Based on the division I did here, the first division statement would be dividend divided by divisor is equal to the quotient, which is what's up here, plus the remainder. Now, you have to be really careful here. Students will make mistakes. It's not just plus 11, it's plus 11 over what number you're dividing by. So it's plus 11/12. Okay. Now, if you did this on a calculator, one that has fractions, you would get this answer. You get 310 and 11/12. Okay, and you can consider that to be the remainder because it's not an integer part. Now, if you do the second form, this one just basically says dividend equals, so the big number that you're dividing by is equal to the divisor, which is the number you're dividing by, times quotient, which is the answer integer part, 310, plus the remainder. Which in this time you do it, it's just the remainder itself. It's not remainder over divisor. Okay, and you put brackets around here, but you don't have to because BEDMAS tells you you would do this first anyways, but this usually reinforces the order you do it if you put the brackets. So that hopefully that takes you back 7 or 8 years. Maybe you remember how to do this. So the style we did this is going to be really similar with polynomials. Okay. Now before we go to the examples, there's a couple of things here I want to talk about. So I already talked about this. Polynomials can be divided in much the same way numbers are, and you just saw me do something with numbers. A polynomial can be divided by a polynomial of the same degree or less. So for example, if I'm dividing, say, a polynomial, a cubic, degree 3, divide that by a cubic or quadratic or linear, 3, 2, or 1, but I cannot divide it by something higher, a degree higher than 3. So the degree that you're dividing by has to be at least as big as what you're dividing. So backwards, the degree of the polynomial that you're dividing has to be at least as big as the degree of the polynomial you're dividing by. Okay. All right. Now, there's another technique that I won't be doing in this lesson. It'll be very, very quick, and it works really well if you have linear factors like x plus 1, x minus 7. So this, and in terms of time, it's very, very fast once you know what you're doing. I'm actually going to do a separate video lesson on this technique. I'm never going to force anyone to use either method. You pretty much have to know this long division that we're going to do, but this could be a time saver and a space saver on your paper. So I will be showing this, like I said, on a separate lesson. The couple other things here, I'll kind of get to these. A lot of talking about it now. So I think we're going to do what, 4 examples. No, 4 examples. And after these examples, you're going to get some practice from the homework. Make sure you try it out. Okay, determine the quotient, which is the result of 3x of this polynomial divided by this polynomial. And you can see the degrees. That's a cubic, and I'm dividing by linear, degree 1. So I'm going to set it up kind of the same way we did the number division. Obviously, these are longer in terms of length of the line, so usually these divisions are quite a bit wider. So what am I dividing? I'm dividing that the cubic there, which is the dividend. So I'm going to put the dividend there. Now, you notice the dividend is already in ascending order of degree of term. That has to be what you do here. So if you happen to get a polynomial, and maybe you'll get one in the next few questions, that's not already written in ascending order, then you're going to have to do that. The only other thing you have to know about doing this is, say they this has degree 3 term, degree 2 term, degree 1 term, degree 0 term. Well, what if what you're dividing didn't have one of these terms? Say it didn't have the minus 7x. If you just left that blank, if you just said 3x cubed minus 5x squared minus 1, you're going to have problems with the long division. So if you're missing a term in terms of the degree, what you have to do is, we call it a placeholder. So if this question was just that, I would actually put plus 0x here. So and we call it a placeholder because it's basically where the x term would be. If you don't see one in what you're dividing by, then you would put a placeholder with a zero coefficient. But we're okay for this. And then you put what are we dividing by? So the divisor is x minus 3. It goes over here. Okay. So it kind of works the same way. So I'm starting with this term here, and I'm kind of saying, well, what do I have to multiply this by? So these two come as a package. I can't just pick and choose. What would I multiply this by to get the 3x cubed? Because I need to get the 3x cubed so I can subtract it and work my way down. So basically you're saying, what do I have to multiply x by to get 3x cubed? Okay, and the answer to that would be 3x squared. Okay, so before we do the multiplication, I know the result so far is 3x squared. Now I'm going to put that above the same degree term that's in the dividend. So the 3x squared would go up here. Okay, and now we go back, because we're not really finished here at all. We have to multiply this binomial by 3x squared. So obviously we know the first one's 3x cubed. That's why we chose 3x squared. And then we multiply 3x squared times negative 3. So that's a negative 9x squared. So basically this line here is 3x squared times x minus 3. Okay, now we subtract. So this time I'm subtracting two things at once, not like with the number, it's only one at a time. So 3x cubed minus 3x cubed, 0, right? I can put a 0 there, I don't have to. That always will happen because we handpicked that number so that it would get rid of that term. Okay, now here we have negative 5x squared. You have to be careful here because we're subtracting. So when I subtract 9x squared, it's the same thing as adding 9x squared. So when I subtract these two, I get a positive 4x squared. Be very careful with your signs here. Okay, and now we go on to the next. Bring down the next term. So that's a minus 7x. Usually we won't put this 0 here. It just kind of clutters things up. And I would keep the sign there just to make sure it's not a negative. All right, and now we do this again. You're saying, working with this first term and this first term, what do I have to multiply the x by to get 4x squared? The answer to that is positive 4x. So you put that up here above the x terms. You see these are all lined up like a normal division would be with numbers. You've got your ones column, your tens column, hundreds, except this time it's degree 0 terms, degree 1 terms, degree 2 terms, degree 3 terms. Okay, so we brought that down. Sign stays the same, and now now we've got the, oh, we already did this, right? So let's see what we get when we multiply 4x times x minus 3. Well, we know it's 4x squared because we picked that. And then you multiply negative 3 times 4x is negative 12x. Okay, now when you subtract, again, the same thing happens. Negative 7x minus negative 12x is the same as negative 7x plus 12x. So you've got a positive 5x here. And then finally you bring down your last term that was up here, which is a negative 1. Okay, and you can tell we're getting close because these are the same degrees. So this will be the last multiplication that we do. What do I have to multiply x by to get positive 5x? Well, that's plus 5x. Sorry, plus 5. Now when I multiply these two together, I get 5x minus 15. And when I subtract, that's gone. Negative 1 minus negative 15 is negative 1 plus 15. So the remainder, and you know you get to the remainder when this degree is less than the degree of what you're dividing by, the degree of the divisor. So you know you're done. And also up here, basically, we're at the end on both of these. So that's another sign sometimes. Okay, so this is the remainder. Like I said, did on the other example, put a r equals beside it. And, you know, it didn't ask for a division statement, but in order to properly communicate the answer, I can say that, well, I can say this one of two ways. I can say 3x cubed minus 5x squared minus 7x minus 1 divided by x minus 3 is equal to, so this is the quotient that we got. It's equal to 3x squared plus 4x plus 5 plus the remainder over, so it's plus 14 over the original thing I'm dividing by, the divisor. So this here is the remainder. You don't have to put these brackets, but this is the, this would be the quotient, and this is the remainder over the divisor. Okay, so that's one way of doing it, or and this is the way I would probably do it. You make it into a product. It's kind of like a product statement. So you can say the thing we're dividing, 3x cubed minus 5x squared minus 7x minus 1 is equal to, it doesn't matter the order you do this. What did we do up there? Divisor. So x minus 3, and we're multiplying with the quotient. Okay, so it's really this times this. Gives us that, but except this time we had a remainder. So this time when you do the statement, you just put the remainder by itself, like that. So you can see this one's a little, I don't know, it's a little more straightforward. It's not the original question, but it at least tells you the relationship between your dividend, divisor, quotient, and remainder. Okay, so there's your first question with a polynomial long division. So hopefully that makes some sense. I'm going to do a couple more on this page, and I'm going to have to squeeze these ones in a bit. I didn't really leave as much room as I should have. So this one, the wording of it is kind of, you know, each of these questions is probably asking a different form of the question, but really all of these we have to do a long division to give the answer to the question we're being asked. So determine the remainder of this. So that's basically saying, you know, do the long division, and I just want to know the remainder. So this is the dividend. So this is what we start with. Now you notice this one is, like I was saying before, It's not in the correct ascending order based on degree, and neither is this. So we have to correct that. So look for the highest degree term, that's x to the fourth minus 2x cubed plus 5x plus 3. And we're dividing by x squared. This time it's a trinomial we're dividing by. Okay, so we had to do a bit of rearranging to get this in the proper form before we start. And now that it is, we're looking at the first two terms here. I'm basically asking, what do I have to multiply x squared by to get x to the fourth? And the answer to that is, oh, I forgot to do something here. Remember I said you had to have every degree represented in the divisor, in the dividend. I don't think, you don't have to have it over here, but definitely you have to have it here. And you can see I'm missing an x squared. Okay, I didn't notice when I was rearranging. So I can't just leave it like that. It's going to create problems. So I actually have to put as plus 0x squared, which is really, it's not changing that. It's just adding a placeholder for the x squared term. And now I can safely put in my x term and my constant term. Okay, so let's pick it up where we left off here. So what do I have to multiply x squared by to get x to the fourth? That's x squared. So I'm going to put the x squared above where this placeholder is, just to keep all the degrees in the same columns. And now we go back and multiply. I have to multiply the x squared with all three of these along here. So x squared times x squared is x to the fourth. X squared times 2x, positive 2x, plus 2x cubed. And x squared times 1 is x squared. So you can see this is, because we're dividing by a trinomial, we're going to have three terms every time we subtract. So now we subtract all three of these. So the first term will disappear, x to the fourth minus x to the fourth. Negative 2x cubed minus 2x cubed. So that's a lot of students might just look at that and say, well, that's 0 too, but it's not. It's actually negative 4x cubed. Okay, then we have 0x squared minus 1x squared. So that's a negative 1x squared. All right, so we're done that. Now we bring down the next term, add it onto the result we just got, and now we pick it up where we left off. What do I have to multiply x squared by to get negative 4x cubed? That's going to be negative 4x. Okay, and now we multiply each of these terms with negative 4x, so negative 4x cubed plus positive 2x times negative 4x would be negative 8x squared. And then finally 1 times negative 4x is negative 4x. Now we subtract, so that's a 0. Careful with the signs again. So that's negative 1 minus negative 8, or negative 1 plus 8. So that's going to be 7x squared. 5x minus negative 4x is the same as 5x plus 4x. Okay, and then finally we bring down the plus 3. And we say, what do I multiply x squared by to get 7x squared? Well, that's pretty straightforward. That has to be 7. And now we multiply each of these with 7, so I get 7x squared plus 14x plus 7. And now we subtract 0, 9 minus 14, negative 5x, 3 minus 7 is negative 4. And this is the remainder right here. Okay, and they didn't ask for the result of this, they just asked for the remainder. So in this case, make sure you're answering the question being asked. Therefore, the remainder is negative 5x minus 4. Okay, so this one had a few new wrinkles to it. First, we're dividing by a trinomial instead of a binomial. And also the original question, we had to reorder it. So it's, I think I've been saying ascending degree, but it should be the descending degree. And we were missing an x squared term in here, so we had to put a plus 0x squared to keep everything there. So we got degree 4, 3, 2, 1, 0. Okay. All right, so hopefully that made sense. Now, this last one here is really what we're using this long division for, because we're talking about factors. Now, the previous questions both had remainders. So if I go back to question 1, example 1, what this is telling me, if you think about it, I'm trying to divide this this quadratic by this, linear factor, and the fact that I got a remainder basically says that this is not a factor of 3x squared plus 4x plus 5. If it was a factor of this, the remainder would be 0. So we're really going to be doing this. We're looking for the cases where there's a remainder of 0, and that would mean, so if I got a remainder of 0 here, that would tell me that x minus 3 is a factor of that. Okay, sorry, a factor of this. And the other factor would be this, because what that would tell me if the remainder was 0 is this times this gives me this. Okay, as soon as you have a remainder, that's not true. And same thing here. There's a remainder left over here, which tells me that this quadratic is not a factor of this quartic, because it doesn't divide in evenly. Okay, so this question here is kind of working towards what we really want. Determine whether x plus 2 is a factor of this degree 4 polynomial. So if we want to know if it's a factor, we're going to divide this by x plus 2 and determine is the remainder 0, and if it is, that means that it is a factor. So same process, it's just we're using the result in a different way. So this one, again, we got to clean up the order to put it in descending order. So x to the 4th minus 2x cubed. Now again, we're missing an x squared term, so I have to put a 0x squared, and then plus 13x minus 6. Okay, and we're dividing it by x plus 2, hoping it divides evenly. X to the 4th, well, that would be x cubed. And then we multiply x cubed with both of these. We get x to the 4th plus 2x cubed. Okay, those cancels. X to the 4th minus x to the 4th. And careful here again, because this does not cancel because we're subtracting. So negative 2x cubed negative 2x cubed minus 2x cubed is going to be minus 4 cubed. Okay. Now, so we're going to bring down this 0 x squared and start this process again. What do I multiply x by to get negative 4x cubed? That would be negative 4x squared. Okay, and now multiply negative 4x squared with both of these. So we get negative 4x cubed, and then that would be negative 8x squared. When we subtract, we get positive 8x squared. And now we bring down the next term. Okay, and what do we multiply x by to get 8x squared? That would be plus 8x. So now multiply 8x with both of these. It's going to be 8x squared and plus 16x. When we subtract, we get 0 here. Here we get negative 3x. And then we bring down the last of our dividend. And what do I multiply x by to get negative 3x? That's negative 3. So negative 3, both these gives me negative 3x minus 6. And that is good news because when I subtract, I get 0, which is the remainder. So what this has basically told me, just to show you what I mean, it means when I do like a division statement here, I can say that x to the 4th minus 2x cubed, and now I can leave out the 0x squared, I don't really need it, plus 13x minus 6 is equal to x plus 2 times what I was dividing by. The order here doesn't matter. X cubed. Sorry, it's the result here. X cubed minus 4x squared plus 8x minus 3. And you notice because there's no remainder, when I add 0 onto the end of this, you can see this is factored. It's much more obvious when you see it this way. So basically, what we just learned is, therefore, x plus 2 is a factor of this degree 4 polynomial. Okay, so that's very useful because it's going to allow me to do several things. Let's go one step further with this last question. This is getting really close to why we're doing this process. This one, it's actually telling me one of the factors of this function, which is a cubic, f of x. It says determine the other factors, then determine zeros and sketch a graph of the polynomial. Okay, so they've already told us that this is a factor of f of x, so that means I should be able to divide this expression by that factor, and I better get a remainder of 0 or they're not telling me the truth, and the answer I get will be the other factor. So let's do that. So I've got my dividend, 6x cubed plus 5x squared minus 16x minus 15 divided by 2x plus 3. Okay, so hopefully you're seeing this pretty quick now, how we do this. We multiply 2x by, we multiply it by 3x squared. So I need a 3x squared, I put it above the x squared term. Now multiply this with both terms. So I get a 6x cubed plus 9x squared. Subtract, we get negative 4x squared. Bring down the minus 16x and do it again. What do we multiply 2x by to get negative 4x squared? That would be negative 2x. Multiply the negative 2x with both of these, we get negative 4x squared minus 6x. Subtract, that's a 0. This becomes negative 16 plus 6, 10x. Bring down the last term, minus 15. What do we multiply 2x by to get negative 10x? That's a minus 5. Multiply both these terms with a minus 5, negative 5. I get negative 10x minus 15. That's great. That means the remainder is 0. That confirms that that was the 2x plus 3 is a factor of that. But it also gives us, sorry, it's a factor of this. It also tells us the other factor. So let's now write this out. I'll do it down here. So basically 6x cubed plus 5x squared minus 16x minus 15 is equal to, and I'll put this 2x plus 3 first, and then I've got 3x squared minus 2x minus 5. So we've got a linear factor and a quadratic factor. So what we need to try to do here, if you notice the question said determine the other factors, so more than one. So we're looking at that saying, well, that's one, but we can factor this quadratic. This would be using obviously the quadratic formula, or a probably quicker way is the complex factoring. You know this, well, actually we don't know for sure if it's factorable, but in this case they've kind of told us that. So if you know, because these are prime numbers, the 3 and the 5, you know, you can have a 3x and an x, and a 5 and a 1. So it's just a matter of which one goes where, and if you try this out, you're going to get a minus 5 there and a plus 1 here. So that gives you negative 5x, that gives you positive 3x, that creates the negative 2x. You get the negative 5 there and the 3x squared there, so that works. So here are the three factors. So if you set each of these to 0 and solve, sorry, I guess I was not in the picture there. So those are that's the original factor that you knew about. That was the result of factoring this out of there. And then we took that and factored the quadratic into two linear factors. If we want to find the zeros for our sketch, set each of these equal to 0, and hopefully you know how to do this. That's going to be positive 5/3 and negative 1. Okay, so those are the three zeros, 3 x-intercepts. What else do we know about this from before? Well, if I'm looking at, you know, that's an odd degree function, positive leading coefficient. So the end behavior we know should be quadrant 3 to quadrant 1. Okay, and we also know the y-intercept. That's the constant. So it's equal to negative 15. In terms of the degree of the factors, since I only had one of each of these are degree 1, so they're going to cross the x-axis on the graph with a fairly straight line. So now I do my sketch. And let's put some important points. So the x-intercept, we'll make that right down at the bottom. And the zeros, so they're all pretty close to 0. So I'll do a 1 and a 2, and negative 1, negative 2. So negative 3/2 is here. Positive 5/3, that's like 1 2/3. It's there. And a negative 1 is here. Okay, and remember the end behavior has that. And we know each of these cross. Okay, so if you think about it, this is going to come up here and then come back down halfway between. So again, we don't know yet how to find how high it goes. We do know it's halfway up. So all right, now we encountered this before. Should I just assume that this is you know, a minimum? No, you shouldn't. So you can determine what the x value of the minimum is, because it's going to go down here and come back, and the minimum value, or the turning point, will be halfway between these two. So remember, that's 1 2/3, and that's negative 1, so 2 2/3. So I believe it's about here that you're going to see the minimum. So it's got to be lower than there, than the y-intercept. And then you're going to have a mirror point there. So there, that's what it's going to look like. And then I'll just kind of connect these. And then this will come up and just keep going. So that's a pretty good sketch. Once we're able to take this cubic and, well, we kind of got a bit of a cheat code there because they told us one of the factors. We're actually going to get around that and be able to find that first factor ourselves. But once we knew that one factor, we were able to get the other two factors, okay, by doing the polynomial division, which gave us, you know, once we divide out one factor, we would get another factor that goes with it. And that might be factorable, which it was. So this is basically what we're going to be doing with this long division is once we know a factor, divide it out from the main polynomial and then keep working down until we can't factor anymore. Okay, so there are some homework questions here. Now when I say odd or even on these, it doesn't mean just do 6, 8, and 10. It probably means a lot of these questions are multi-part questions, A, B, C, D, E, F, whatever. So when I say odd or even, you do like every second one. I wouldn't expect you to do every single one. That's a lot, way too much work. You can pick, just do as many as you think you need in order to become very good at this. So give that a try, and we'll be using this skill in our remaining lessons in this unit. So good luck with that, and we'll talk to you in the next lesson.